Hi everyone, and welcome to this tutorial session. In today's tutorial, we are going to see a question that's about the relationship between the roots of a quadratic equation and the coefficients of that quadratic equation. Now the question goes thus. The roots of the quadratic equation x squared minus x plus 2 equals 0 are alpha and beta. Prove that A 1 all over 1 plus alpha squared plus 1 all over 1 plus beta squared is equal to negative half. B 1 all over 1 plus alpha squared multiplied to 1 all over 1 plus beta squared is equal to a half. Hence, form a quadratic equation whose roots are 1 all over 1 plus alpha squared and 1 all over 1 plus beta squared. Ladies and gentlemen, we are all encouraged to follow this solution from the beginning to the end because it is very, very interesting. There's a lot of insight that you're going to get from this solution. All right, so let's start. Now, the question, our quadratic equation given is x squared x squared minus x plus 2 is equal to 0. And we are told that it has roots alpha and beta. Now, this question is on the relationship between the root of a quadratic equation and the coefficients. Now, let's revise that. Given any quadratic equation, ax squared plus bx plus c equals 0, and if we are told that the roots are alpha and beta, like we have up there, now there is a relationship between the coefficients of this quadratic equation and the roots alpha and beta. Let's first of all collect the coefficients. The coefficient of x squared term is a, and the coefficient of x term is b. The coefficient of, or the constant term, is c. Now we know that sum of roots, which you can just represent as alpha plus beta, is equal to negative b all over a. And we also know that product of roots, which can be represented as alpha multiplied to beta, is c all on a. Okay, so this is the relation between the various coefficients of the quadratic equation and the root of a quadratic equation. We are going to work with this knowledge. Okay, now let's look at our equation. We have x squared minus x plus 2 equals 0. Let's have our coefficients. A is the coefficient of the x squared term. The coefficient of the x squared term there is 1. B is the coefficient of the x term. The coefficient of x term there is negative 1. And C is the constant term. We should always make sure that we collect this information accurately because the least error will just make your work a messy lot. Now, from here, and we are told that sum of roots, let's just represent sum of roots as SR, product of root as PR to ease our writing. So we have sum of root SR is alpha plus beta. We were told that alpha and beta are the roots. So we know it is negative b all over a. So that gives us negative b. B is negative 1. So we have negative 1 all over our a is 1. This gives us negative is 1. So we have alpha plus beta is equal to 1. So we can write that down here and put it in a box. Alpha plus beta is equal to 1. This is our first major information that we have. Next, product of roots. Product of roots, alpha, beta. Product of root is c all over a. Our c is 2 and our a is 1. So this gives us 2. So we can also write this now and put it in a box so as to remember alpha beta is 2. This is our second major information that we have. Okay, now we are going to use these two information to be able to answer the questions in A and B. Now A says we should show that 1 all over 1 plus alpha squared plus 1 all over 1 plus beta squared. We should show that it is negative half. We need to show that this gives us negative half. Alright, this is a fractional expression added to another fractional expression. We proceed in the same manner when working with numbers. We get the LCM of the denominators. The easiest LCM is simply their product. So have 1 plus alpha squared multiplied to 1 plus beta squared. That's the simplest LCM. Now, this LCM divided by that, we can see 1 plus alpha squared, we just cancel 1 plus alpha squared, and we're left with 1 plus beta squared. 1 plus beta squared. This LCM divided by 1 plus beta squared, 1 plus beta squared will cancel out when we do that division. And so we're left with 1 plus alpha squared. So we have 1 plus alpha squared. Okay, so this gives us, let's arrange what we have at the numerator. We have 1 plus 1, so we can just call that 2, plus alpha squared plus beta squared, all over. We have 1 plus alpha squared into 1 plus beta squared. Now, look at our two main information that we are going to work with, alpha plus beta and alpha beta. So how do we bring in alpha plus beta or the product alpha beta in this expression? We should remember that when we have expressions like this, a plus b all squared, then we know it is a plus b multiplied to a plus b. So if we open out this parenthesis, we're going to have a multiplied to a is a squared, a multiplied to b is ab, b multiplied to a is ab, b multiplied to b is b squared. This gives us a squared. Ab plus ab is 2ab plus b squared. This is what we have. Now, if we look over there, we can rearrange this as a squared plus b squared. That's taking this, and then plus 2ab. Remember, this is a plus b all squared is this. So, what is a squared plus b squared? Alright, let's write this one out. A plus b all squared is equal to this. We want to isolate this. To isolate this, we simply take this one, 2ab, from the right hand side to the left hand side. So we'll have a plus b all squared minus 2ab will give us a squared plus b squared. Alright? So a squared plus b squared is now represented like this. So here we can see a sum and we can see a product. So the same thing will go when we replace alpha with a and replace beta with b. Okay? So we see here, a squared will become your alpha squared, b squared will become your beta squared. So wherever we see a, we'll put alpha, and b will put beta. So we have 2 alpha beta minus alpha plus beta all squared. So when we copy from this, all right. So now we said we want to bring in alpha plus beta and want to bring in the product alpha beta. We now see that in the place of alpha squared plus beta squared, what we have here, we can bring in alpha plus beta, whose value we know, alpha beta, whose value we know, to replace this one. And so we can just go ahead now and write this expression, this one up here. Let's write it again. 2 plus alpha squared plus beta squared all over 1 plus alpha squared into 1 plus beta squared. This can be written as 2 in the place of alpha squared plus beta squared. Alpha squared plus beta squared, we're going to write this lot. So 2 plus alpha plus beta all squared minus 2 alpha beta all over. Now let's open this parenthesis at the denominator. If we open this parenthesis at the denominator, we have 1 plus alpha squared, 1 plus beta squared. 1 multiplied to 1 is 1. 1 multiplied to beta squared is beta squared. Alpha squared multiplied to 1 is alpha squared. Alpha squared multiplied to beta squared is alpha squared beta squared. Now, look at this. Look at this. We're having alpha squared plus beta squared again. Alpha squared plus beta squared. So we'll replace this with this expression. Remember, we want to have the sum and product. Our aim is to replace everything with sum and product. So this one, we will now replace it with this expression that we have here. All right. And then this one we already know. So we can just say this is 1 plus alpha plus beta all squared minus 2 alpha beta plus alpha beta all of that squared. Okay, so we just come here, we write it there. It's 1 plus alpha plus beta all squared minus 2 alpha beta plus alpha beta all of this squared. Okay, what we have done here is to bring in our alpha plus beta and our alpha beta from this our expression. So everything now here has been arranged having this and this inside. So let's write it again this way so that we can see clearly and we proceed with our work. We are saying 2 plus alpha squared plus beta squared all over 1 plus alpha squared 1 plus beta squared is the same as 2 plus alpha plus beta all squared minus 2 alpha beta, all of that divided by 1 plus alpha plus beta all squared minus 2 alpha beta plus alpha beta all of that squared. So we're going to be able to use our main information. Now, this gives us 2. We found that alpha plus beta was equal to, we found that alpha plus beta was 1 and alpha beta is 2. So in the place of alpha plus beta, we're going to write 1 squared minus 2 into 2 all over 1 plus 1 squared minus 2 into 2 plus 2 squared. And we'll put in the values of alpha plus beta and alpha beta. It gives us 2 plus 1 minus 4 all over 1 plus 1 minus 4 plus 4. This gives us 2 plus 1 is 3, 3 minus 4, 1 plus 1 is 2, negative 4 plus 4 is 0. So finally we get 1, negative 1, 3 minus 4 is negative 1, negative 1 all over 2. Okay, that ties. All right, so we have answered question A. Question A was to prove or to show that that sum is negative half. Now let's do B. B says we should show that the product of 1 all over 1 plus alpha squared multiplied to 1 all over 1 plus beta squared, show that it is positive half. This is what we need to show for B. We will carry out the same line of reasoning. Our aim is to bring in alpha plus beta, which is 1, and the product alpha beta, which is 2. Our aim is to bring in that sum and that product. We have 1 all over 1 plus alpha squared multiplied to 1 all over 1 plus beta squared. Now, this is a fractional expression multiplied to another fractional expression. Nothing to cancel, either cancel as such or like this. Nothing to cancel. So numerator multiplied to numerator, 1 multiplied to 1 is 1, and then the denominator 1 plus alpha squared multiplied to this other denominator 1 plus beta squared. Remember this expression we had earlier on, so but let's still do it. There's no problem. 1 multiplied to 1 is 1. 1 multiplied to beta squared is beta squared. The alpha squared multiplied to 1 is alpha squared. Alpha squared multiplied to beta squared, we have alpha squared beta squared. This gives us 1 all over 1 plus, in the place of alpha squared plus beta squared, we already had it as alpha plus beta, all of that squared minus 2 alpha beta. Now, alpha squared beta squared is simply alpha beta all of this squared, since they have the same power, power 2, power 2. Alright, we have transformed everything in terms of the sum and product. So let's put in our values. So we have 1 all over 1 plus 1 squared minus 2 multiplied to 2 plus 2 squared. We have 1 all over 1 plus 1 squared minus 4 plus 4. Again, minus 4 plus 4 is 0. So this gives us 1 all over 2, which answers the question B. So we have shown that this product is actually a half. Now, the last part of our question says we should find the new quadratic equation whose roots are 1 all over 1 plus alpha squared and 1 all over 1 plus beta squared. So, we want to find new quadratic equation with roots 1 all over 1 plus alpha squared and 1 all over 1 plus beta squared. So these are our new roots. How do we get that? Remember the nature of the equation is x squared minus sum of new roots times x plus product of new roots equals 0. That's the nature of the quadratic equation that we have to form. So what we need to do now is to get the sum of new roots and product of new roots. Now, earlier on, we saw that 1 all over 1 plus, that was our A, the question we solved in A. 1 all over 1 plus alpha squared plus 1 all over 1 plus beta squared. We found that to be negative half. Alright? If you look at it, it's actually the sum. When we're adding, it is sum. Our new roots there was 1 all over, our new roots are 1 all over 1 plus alpha squared, 1 all over 1 plus beta squared. So when we're adding, it's actually the sum of new roots. So this one just gives us what we have been writing as sum of new roots. S subscript NR, sum of new roots. So we already did that. And we also saw in B, what we did in B, this product 1 all over 1 plus alpha squared into 1 all over 1 plus beta squared. We found this to be a half. If you look at it carefully, it's actually our new roots multiplied together. Alright, our new roots multiplied together. So this is already the value for product of new roots. So all we need now do is to take these values and put in the form of the quadratic equation. So our equation, which has the form x squared minus sum of new roots multiplied to x plus product of new roots is equal to 0. So it will just give us x squared minus our sum of new roots is negative half, that multiplied to x plus product of new roots is a half, is equal to 0. Okay, so all we now have to do is to write it in the form ax squared plus bx plus c equals 0. That can be done by multiplying all through by 2. Or multiply all through by 2, we're going to have our new quadratic equation. If we multiply every term here by 2, we're going to have 2 into x squared minus a half x plus a half equals 0. So multiply all through by 2. That gives us 2x squared. 2 multiplied to a half, the 2 will cancel there. You have minus x. 2 multiplied to a half, that 2 cancels that 2. We have plus 1 equals 0. So this is the new quadratic equation with integral coefficients whose roots are 1 all over 1 plus alpha squared and 1 all over 1 plus beta squared, formed from a quadratic equation x squared minus x plus 2 equals to 0 with roots alpha and beta.